Welcome back. In the last video, we explored different ways to spread the laser power and collect Raman signal from different points at once. Today, we are diving into how to optimize the laser power for the Raman imaging. Different samples can handle different amount of laser power. Some might be burned with just a fraction of a milliwatt, while others can take hundreds of milliwatt without problem. To control the laser power, we often use ND filters, short for neutral density filters. These act like sunglasses for the laser, reducing its power. A set of ND filters, or even better, a variable ND filtering system, gives you the flexibility to dial in just the right amount of laser. But laser power is only part of the story. We also need to think about the laser intensity. That's the laser power divided by the area of the laser's focus. The same power, focused tightly or spread out, can have very different effects on your sample. Things like objective length, laser's wavelength, beam size, all affect the size of that focus spot. Here's something that often gets overlooked. The order in which you scan your sample can also make a big difference in temperature. Usually, Raman imaging happens point by point, line by line. If you are scanning points close together on the sample that doesn't conduct heat well, the area can heat up slowly and get damaged. There's a clever trick. Instead of scanning points one after another in a straight line, try using a random sequence. This gives the sample time to cool down and prevents overheating in one small area. However, moving among measurement points in random sequence is not very straightforward and needs specialized hardware. Let's cover this in another video later. Thanks for watching and see you next time.